Hello everyone. Today the topic that we are going to study is Introduction to the Modern Periodic Table. So you must have studied the periodic table that was given by Mendeleev, right? But this is the modern periodic table which we follow now. It was developed by Henry Moseley in 1930. Now, what is special in this periodic table? The earlier periodic table that was given by Mendeleev, it followed basically the elements were arranged in the increasing order of their atomic masses, because of which there were some problems that were being faced in the arrangement of elements, right? Okay. Now here in this table, the periodic table, this problem was rectified and elements are arranged in the increasing order of their atomic number. What is the atomic number? Okay. In any atom, for example, let us consider sodium. So the atomic number is 11, right? 11 means it has 11 protons and 11 electrons. So atomic number is nothing but the number of protons, right, which is there. So it is present in the nucleus, right? So that is a much more better fundamental property of an atom rather than its atomic mass, because one atom like carbon, it can have two different isotopes, right? So we won't be able to place both of them in the periodic table, and two different isotopes have different masses. Okay, so we arrange here, the elements are arranged in the increasing order of their atomic masses, starting from hydrogen, the atomic number, the atomic number is 1, helium it is 2, lithium is 3, and so on. And this periodic table solved many issues that were there in the Mendeleev's periodic table. This is also known as a long form of the periodic table. Okay, let us start with the structure of this periodic table. So here there are 7 horizontal periods that are called rows, which we are going to see now. And there are 18 vertical groups, which are called columns. And here this periodic table is divided into S, P, D, and F block, which is again based on the electronic configuration. Let us see. Okay, so first you can see here that we have, okay, how many groups did we say? We had 18 groups, right? So how can we can count it like this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And here we have 13, 14, 15, 16, 17, 18. So we have 18 groups, right? Which are like vertical columns. Okay. And then we have 7 horizontal rows like 1, 2, 3, 4, 5, 6, 7. We call them the period, right? So in this modern periodic table, we have 7 periods and we have 18 groups. That is what we have to know and we should know, right? We are studying chemistry. Okay, and now this entire periodic table, if you would see, it is divided into 4 blocks. If you can see, the first 2 groups, they come into the S block. After that, the next 10 groups, they come into the D block, and the next 6, they come into the T block. After that, we even have F block, which is starting from here actually after lanthanum. You can see number 57, lanthanum, right? It is in the middle. Right, it comes from the middle, so it is known as the F block, right? So this is how the periodic table is divided into 4 different blocks. And these blocks have their own properties, which you will be studying in detail, as we move forward. Okay, so yes, they are divided based on the electronic configuration. So I think in chapter 2, you have learned about, electronic configuration. For example, if I write the electronic configuration of beryllium, it is 1s2, 2s2. So all the elements whose last electron enters into the S subshell, they will enter into the S block. Okay, and the elements whose last electron enters into the D subshell. For example, scandium is argon 4s2, 3d1, right? That is argon 4s2, 3d1. Okay, so here the last electron, as you can see, is entering into the D subshell. That's why it is placed in the D block. And all the P block elements, the last electron enters into the P subshell. So you can write the electronic configuration and see. F block element, the last electron enters into the F subshell. That is why, they have been arranged in different blocks. Let us move forward. So basically group 1, so these are different names that have been given to these groups. Group 1, we call them the alkali metals, right? Group 2, we call them the alkaline earth metals. Group 3 to 12. Okay, so this is the alkali metals, group 1, and group 2 is the alkali earth metals, right? Now D block, it is known as a transition, these elements are known as a transition elements. So you can see it is kind of, showing us a transition from S to P. And also the elements that are present in the D block, they also have properties, that show a transition between D to P, right? P block elements are all non-metals mostly. S block are all metals, right? D block are also metals. So it's kind of showing like a transition, hence the name transition elements. Group 18 is known as noble gases. Now, why are they called noble gases? So if I would highlight, this is the group, these are the group 18 elements, that is the last group. They have completely filled electronic configuration. For example, if I would write for argon, so argon, the last shell is completely filled. Its atomic number is 18. So the configuration becomes 2, comma. Okay, so atomic number is 18, so it becomes 2, comma 8, comma 8, right? And the last shell can hold only 8 electrons, right? Since their configuration is complete, they don't want to gain electrons, they don't want to lose electrons to become stable, hence they are called noble gases. Noble means, what does the word noble means? It means, okay, if I talk about a noble person, it means a person who never fights, right? A person, who does good deeds. So these elements, they never react with other elements, right? Because their shell is completely filled. So group 18 elements, we also call them as the noble gases, right? Group 17 elements, that is the halogens, fluorine, chlorine, bromine, iodine, astatine, okay, and tennessine. They are called as halogens. That is the name given to group 17, okay, group 17 elements. Okay, let us move forward. Okay, so we know that the period number is equal to the number of shells. For example, let us see here, there are 7 periods, and each period actually, okay, if an element sodium is in the third period, if you can see it is in the third period, that means it has 3 shells. Okay, let us draw sodium. So if we would draw sodium, the atomic number is 11. So, okay, this is the nucleus which I am representing. Then I have the first shell which has 2 electrons. Then I can draw the second shell which has 8 electrons, and the third shell that has just 1 electron. So we can draw it like this. So hence you can see there are 3 shells, right, corresponding to the period, right? Okay. So corresponding to the third period, sodium has 3 shells. Similarly, if you would see, if I would ask you, can you tell me rubidium has how many shells? So you don't have to calculate. You can just see, okay, rubidium is in the 5th period. So there will be 5 shells. And what does the group number tells us? The group number tells us the number of valence electrons, right? Let us move forward. Okay. So since there are 7 periods and each period has, okay, different number of elements, let us understand. Okay, so the first period has only 2 elements. Second period has 8 elements. Third period also 8. Fourth and fifth period have 18 elements. Okay. Sixth and seventh period, they have 32 elements because, okay, let us talk about the sixth period. Here, there are also like there are 18 elements, right? S, D, and P, like 2 elements from the S block, 10 from the D, 6 from the P block, and 14 from the F block are also being added. That's the reason, right? Okay, so this we should know that the first period contains only 2 elements, second and the third period contains 8 elements, fourth and the fifth period contains 18 elements, and the sixth and the seventh period it contains 32 elements. Okay. So based on the valence shell, as I already told you that, these elements, they are classified based on where the last electron is going. Last electron means that electron is present in the valence shell. What is the meaning of valence shell? Valence shell means the last shell, right? So if I talk about S block, so in S block, there are groups 1 and 2, right? So here the last electron is entering into the S subshell, hence that is called as S block. Group 13 to 18, right? There are 6 groups. So here the last electron is entering into the P subshell, hence they are placed in the P block, right? In D block, the last electron enters into the D subshell. That is why they are placed in, between groups 3 to 12. F block, they are called, they're also known as lanthanoids and actinoids. They're known as inner transition elements. Okay, so I would just show you where are the lanthanoids and actinoids. If you would see here, this series, the 4F series, the top one, we call it lanthanoid. As you can see, the first element here is lanthanum. Lanthanum is a D block element, but we have placed it here in the, the F block because it has properties similar to F block, but it is placed here as well. So lanthanum is a D block element. Actinium, and because of actinium, this entire series is called actinoids. Actinoid is also a D block element. Actinium is a D block element, but we have placed it here because it has properties similar to F block. So these are the F block element, these 14 on the top and the 14 below, which are forming the lanthanoid and the actinoid series. Okay, let us move to the main part, which is very important for this chapter, that is the periodic trends, right? So we have the periodic trends. Now, what does the periodic trends mean? It means that, as we are moving left to right, or as we move down the group, what is happening to certain properties like the atomic size, like the electronegativity, or the ionization enthalpy. Let us come to atomic size. So what is happening to atomic size, when we move from left to right or when we move down the group? Okay, first let us understand down the group. Okay, if we are moving down the group, as I already told you, period number represent the number of shells. So in the first period, there will be one shell, second period, two shell, third period, fourth shell, right? So as we are going down, isn't it the number of shells are increasing? And if the number of shell increases, isn't it the distance from the nucleus to the outermost shell increases, right? The distance from the nucleus and the outermost shell increases. So that is the reason, that is the reason that the size increases when we are moving down the group. So I will just show you the periodic table. If you can see here, we have hydrogen, lithium, sodium, potassium, rubidium. So francium, that is the last element, would be the greatest in size because it has 7 shells. Obviously, 7 shells. So the distance between the nucleus and the outermost shell would be more, right? Okay, now let us understand what is happening to the atomic size as we go from left to right. As we go from left to right, what is happening? Let us consider the third period, that is sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. Okay, as we are third period, all of them would have 3 shells, right? But the number of protons would increase, right? For example, I consider sodium, magnesium, aluminium, right? And silicon, phosphorus, sulfur, chlorine, and argon. So all of them have 3 shells, but they have different number of protons. Like sodium has 11, magnesium 12, 13, 14, 15, 16, 17, and 18. And protons are positively charged species which are present in the nucleus. Isn't it? If the shell number is the same, right? So the electrons are added in the same shell, like they will be added in the third shell. But if the proton has more nucleus, right? That means the nucleus now has more positive charge. Isn't it the positive charge in the nucleus would attract the outermost electron with a greater force, right? So let us consider argon. So in argon, there are 18 protons in the nucleus, right? And the number of shells are the same. So electrons are added in the same shell. But the protons, the positive charge, the nucleus, it will exert more force on the outermost electrons and pull them basically. So there will be a slight contraction, because of which, as we are moving from left to right, gradually the size decreases because the effective nuclear charge, the term is called effective nuclear charge. Effective nuclear charge increases. Hence, when we go from left to right from the periodic table, this is the left side, this is the right side. If you go from left to right, the size would gradually, slowly, it would decrease, right? Because of the increase in the effective nuclear charge. But if we are going down the group, what is happening? Size is increasing because one new shell is being added every time. That's the thing. Okay. Now, let us move on and study the next trend. Yes, next trend is called the ionization energy. Now, I think you all already know what is ionization energy or ionization enthalpy. Let us study. Ionization energy or ionization enthalpy is amount of energy that is required to remove an electron from the outermost shell, right? Okay. So if we are moving down the group, let us consider, if we are moving down the group, the atomic size increases, right? So if the atomic size increases, the nucleus is not holding on to the outermost electron with a greater force. So as we are moving down the group, it becomes very easy for us to remove an electron. Hence, the ionization enthalpy or the energy decreases down the group, right? Okay, next. When we go left to right across a period, I told you that the size decreases. And I also told you why size decreases. It is because of the greater effective nuclear charge. So if the nucleus is holding the outermost electron with a greater force, what happens? What is happening, that the ionization enthalpy in this case would increase, because now it becomes very difficult to remove an electron because the size is small. And now this ionization energy depends on the force of attraction between the nucleus and the outer electrons. So obviously, if you're moving left to right, if the size is becoming small, 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 isn't it the force of attraction between the nucleus and the outermost electron increases? That is the reason you have to supply more energy to remove the outermost electron. Hence, the ionization energy, it increases across a period, right? Okay. Now, let us study what is the importance of the modern periodic table. When we connect through Urban Pro, if we take classes, so maybe we can study all the trends of the modern periodic table, right? Now let us study the importance of the modern periodic table. That is, you can predict the properties and the reactivity. Like even if I tell you, okay, if this element is in group 2, so you can tell me, okay, it has 2 electrons in the outermost shell, right? So you can predict its property that, if it is in group 2, it would be a metal, right? So we can generalize the properties. Otherwise, there are so many elements and it would take so much time for us to study the property of each and every element. But grouping the elements together, it saves time for us to learn about the properties of elements, right? Okay, so it predicts the properties and the reactivity. It explains the atomic structure. Also, it is the foundation of systematic study of elements, right? So this is the importance of the modern periodic table. Okay, so before ending the class, let us just revise the main point. What is the main point? The modern periodic table, the elements are arranged in the increasing order of the atomic number, right? Okay, and there are 18 groups and there are 7 periods. That is what we have to remember. And all of these elements are classified into S block, P block, T block, and F block. And then there are certain trends, and today we saw 2 trends, that is about the atomic size and the ionization enthalpy. Let us see some questions. Okay, who proposed the modern periodic law? And I told you this in the very beginning. Who proposed the modern periodic law? Yes, it was Henry Moseley who proposed the modern periodic law. How many periods are there in the modern periodic table, right? So can you tell me this answer and maybe you can comment it down below. How many periods are there in the modern periodic table, right? I told you this just right now. Which group contain noble gases, right? So this also we had discussed recently. Okay, what happens to the atomic size down a group, right? Please let me know in the comment box. Does it increase, decrease, it remains the same, or does it doubles? Okay, which block contains the transition elements, right? So we had studied that, one of these block, the elements in that block, they're also known as transition metals, right? So answer these questions and check, how much you have learned today in the class. Okay, thank you. Thank you for your attention. And if you want to learn more and if you want to go deeper, we can connect through the Urban Pro profile, right? Thank you so much.